Okay, so let's dive right in. We're tackling a really foundational topic today, essential statistics concepts.
Yeah, super important for anyone working with data.
Exactly. And we're digging into the source material you shared with us, that article outlining 6 key ideas for data analysis.
Mhm.
Our mission, really, is, just for you listening, we want to quickly unpack these core concepts from the article.
Sort of a shortcut, you could say.
Yeah, exactly. A shortcut to getting how data is described, how it's analyzed, and, interpreted.
And it's fascinating how these concepts build on each other. The source really emphasizes that they're the bedrock for making sense of numbers.
Right. It starts pretty logically, with just describing what you've got.
Descriptive statistics, that's the first one the article mentions.
And this isn't about, like, predicting the future or anything.
No, not at this stage. It's purely about summarizing, presenting your data clearly, an executive summary for your numbers almost.
Okay.
So the source talks about measures of center, mean, median, mode, and crucially, why you'd pick one.
Oh, right. Like the median being better if you have really extreme values throwing things off.
Exactly.
Yeah.
The article touches on that with skewed data. That's a key point. And then there's spread, standard deviation, variance, how spread out things are.
Got it. So summarizing the main features. Okay. But what about figuring out the chances of something happening? Likelihood.
Yeah, that leads straight into probability. It's all about putting a number on uncertainty.
Quantifying it.
Precisely. The source mentions things like, are events independent or dependent? Does one outcome affect the next?
Okay.
Understanding that basic probability language is, well, it's essential for the next big step the article covers.
Which is making inferences, right? Going beyond just your data.
Exactly. Inferential statistics. This is where it gets, I think, really powerful.
Taking a small piece, a sample.
And using it to learn something, draw conclusions about the much bigger picture, the whole population it came from.
How does that work, though, in practice?
Well, the source explains it involves tools like hypothesis testing. You set up a claim, like a baseline idea,
Okay.
and then you use your sample data to see if there's enough evidence to say, maybe that initial claim isn't right.
And that's where things like p-values come in, weighing the evidence.
You got it. The p-value helps you assess that, asking essentially, if my initial claim was true, how likely would I be to see data like this?
Right. Makes sense. But, okay, when we're looking at data, especially relationships between things, there's that huge warning sign the source puts up.
Oh, yes. Correlation versus causation. Absolutely critical.
It seems to trip people up all the time.
Constantly. And the article is spot on to hammer this home. Correlation just means two things tend to move together, an association.
Like the example of ice cream sales and crime rates.
Perfect example. They're correlated, both go up in summer. But, as the source makes clear, one doesn't cause the other. There's a third factor, the heat.
And mixing those up is where data gets really misleading.
Hugely misleading. The source rightly warns about that.
Okay, so if correlation isn't causation, but we do want to understand relationships we see, what then? The article mentions regression.
Yes, regression analysis. That's about building models, mathematical ones, to describe how variables relate.
So how one thing changes when another changes.
Pretty much.
Yeah.
Simple linear regression if it's just one predictor, multiple regression if you've got several influencing factors. It helps you predict or just understand the strength of those links.
Okay, and the final piece the source covers. It's about the data's shape.
Data distribution, yeah. Understanding the pattern your data makes when you plot it out.
Why is that pattern so important?
Because, as the article points out, the distribution often tells you which statistical tools are actually appropriate to use.
I see.
Is it bell-shaped, that classic normal distribution? Lots of tests assume that. Or is it skewed? Or something else entirely? Knowing the shape guides your analysis.
Wow, okay. So quick recap then. We've got describing data with descriptive stats.
Quantifying uncertainty with probability.
Using samples to infer about populations. Inferential stats.
Making that crucial distinction between correlation and causation.
Right. Then modeling relationships with regression.
And finally, recognizing your data's underlying pattern or distribution.
That really covers the key building blocks from the source.
Absolutely.
Yeah.
And truly, getting these concepts, as the article stresses, is fundamental. It's how you unlock the real power of data analysis and interpret things correctly.
It really is. And that warning about correlation and how data can mislead,
Yeah.
it makes you think beyond just doing analysis yourself. Understanding these ideas helps you, the listener, critically look at any statistic or chart someone throws at you every day.
It equips you to ask better questions.
Exactly. So maybe a final thought to leave you with, building on that. Knowing these core ideas now, what questions will you ask differently next time you see a statistic in the news or a chart in a report?
Yeah, how does knowing about, say, the risk of confusing correlation with causation change how you read a headline claiming X causes Y, or evaluate a marketing claim?
Definitely something powerful to consider. Well, that wraps up our deep dives into these essential statistics concepts, all based on your source material.